Have you ever just looked up at the sky and thought, what am I actually breathing in right now? I mean, we take something like 20,000 breaths every single day, but most of us never really stop to think about that invisible world of particles and gases we're constantly taking in. So today, let's pull back that curtain.
So what is it? What exactly turns the very air we need to survive against us? To figure that out, we need to get a closer look at what's floating around in there. And wow, the difference can be pretty stark. On one side, you've got this crisp, clear, beautiful landscape, and on the other, a city just shrouded in haze. It's the same sky, but these are two totally different stories about what's in the air and what that really means for us.
So what is air pollution like officially? Well, the source material defines it as any condition where substances are present in concentrations high enough to cause harm. Now, the key word you really need to latch onto there is concentration. And that whole idea of concentration, it leads us perfectly into our next section. Because if it's all about the amount, well, the big question is, how much is actually too much? Right, and here's the crucial point. A lot of these substances are already naturally in the atmosphere. And at those super low background levels, they're totally harmless. Think of it like salt in soup. A little is fine, maybe even necessary, but too much just ruins the whole thing. It's only when that concentration gets pushed way above its natural level that a harmless substance turns into a harmful pollutant. Now, to really get a handle on all this, it helps to sort these pollutants into two main families. This little distinction is key to understanding where all this stuff actually comes from in the first place.
Think of it like baking a cake. Primary pollutants are your raw ingredients. They get shot directly out of a source, like flour being dumped out of a bag. But secondary pollutants, they're the finished cake. They aren't just emitted, they actually form up in the air when those raw ingredients mix and react with other things. Here is a perfect example of a primary pollutant. That smoke and sulfur dioxide, or SO2 that you see there, is being released directly from those factory smokestacks. It's a straight-up direct emission, a raw ingredient.
Now compare that to this. This thick, nasty smog hanging over the city, it wasn't just pumped out of one giant tailpipe looking like that. No, it was created up in the air when other pollutants got baked by the sunlight. That makes it a secondary pollutant, or finished cake. Okay, so now that we know the two main types, let's meet the usual suspects. There are 5 major pollutants that scientists track to give us a picture of our daily air quality. And here is our lineup. Anytime you hear about the Air Quality Index, or the AQI, on the news, these are the 5 main culprits that number is based on. Why? Because they're the most common and they have the biggest impact on our health. First up, we've got carbon monoxide, or CO. The biggest source for this one? Vehicle exhaust. It's a sneaky one, invisible, odorless, and really not good for you in high concentrations. Next is sulfur dioxide, SO2. This one primarily comes from burning fossil fuels like coal, and it's a major contributor to acid rain. Number 3 is nitrogen dioxide, NO2. A lot like carbon monoxide, it's a big emission from cars and power plants. Fun fact, it's actually what gives smog that ugly brownish color. Then there's particulate matter, or PM. Now, this isn't just one chemical. It's a whole mix of tiny little solid particles and liquid droplets. Soot, dust, fumes, just hanging out in the air. Some of these are so small you could fit hundreds of them across the width of a single human hair. And finally, number 5 is ground-level ozone. This is a textbook secondary pollutant. It's not shot out of a pipe. It forms from chemical reactions, especially on hot, sunny days. It's the main ingredient in what we all call smog. So, we've met the pollutants. The next logical question has to be, where is all this stuff coming from? Let's trace it back to the source. Air pollution doesn't come from just one single thing. It's this complex web of both natural sources and human activities. I mean, we all see the obvious ones, right? Motor vehicles, industrial waste. But if you look a little closer at this, you'll also see natural sources like forest fires, and even things you might not think of, like agricultural activities. It's all connected, and it creates this huge puzzle that you can't solve without understanding all the pieces. So when you boil it all down, the biggest sources really fall into a few key categories. Our industrial processes, the cars and trucks we drive every day, fires, both natural and man-made, our farming activities, and even the garbage that's breaking down in our landfills. So the sources are pretty clear.
The pollutants have been identified, and we understand the process. We can really, truly see the problem now. And that leaves us with one final and really important question. What's it going to take to see clear skies again?